What's up, everybody? In this video, we're going to be covering USACO's 2017 February contest at the bronze level. Problem number 1, why did the cow cross the road, aka Crossroad? While the age-old question of why chickens cross roads has been addressed in great depth by the scientific community, surprisingly little has been published in the research literature on the related subject of cow crossings. Farmer John, well aware of the importance of this issue, is thrilled when he is contacted by a local university asking for his assistance in conducting a scientific study of why cows cross roads. He eagerly volunteers to help. As part of the study, Farmer John has been asked to document the number of times each of his cows crosses the road. He carefully logs data about his cows' locations, making a series of N observations. So N is the number of times he's observed the location of one of these cows. N observations over the course of a single day. Each observation records the ID number of a cow, which is an integer in the range 1 to 10, since Farmer John has 10 cows. Okay, so we have exactly 10 cows. That's not going to change. We won't have more than 10 and we won't have less than 10, as well as which side of the road the cow is on. Based on the data recorded by Farmer John, please help him count the total number of confirmed crossings. A confirmed crossing occurs when consecutive sightings, I don't think that A should be there, when consecutive sightings of a cow place it on different sides of the road. Okay, input format comes from crossroads.in, so we'll have to make a file reader. The first line of input contains the number of observations n, a positive integer at most 100. Okay, so only 100 observations. So there's not a lot of data here. We have 10 cows and 100 observations, which means we shouldn't have to worry about our code running too slowly for this problem. So first line is n, that's 8, so this means there's going to be 8 observations. Each of the next n lines contains one observation and consists of a cow ID number. Cow ID number was the first number, followed by its position indicated by either a 0 or a 1. 0 for one side of the road, 1 for the other. Okay, and so that's what all these observations are. Output goes to crossroads.out. Please compute the total number of confirmed crossings. Okay, now this seems like this is super straightforward at first, but this actually has a little bit of a tricky twist to it. And the reason why is because the first observation of a cow, for example, this 3-1, that is not a crossing. But we need to be able to recognize when we have a cow for the first time that they have not crossed the road. But then when we have a cow for the next time, they may or may not have crossed the road, depending on what side of the road we've observed them on. So, for example, if I were to set up just an array of zeros and initialize it all to zeros, and then read that, oh, cow 3 is on side 1, and I record that as a change, that's not a road crossing. The first observation for any given cow doesn't qualify. So this is a bookkeeping problem, but it does have a couple little tricky twists to it as far as how you're going to keep the books. Couple ways you could do this. One is you could use some sort of a map or a dictionary. Those are very easy to use in Java and in Python in particular. The other way you could do it would be like an array. With an array, though, you have to keep track of 3 states. So we can't do a Boolean array. We need to know whether or not the cow is on side 1 or side 0, or whether or not that cow has never been observed. So we've got 3 states. So real quick, I'm going to run over the array solution. Using a primitive array or a list probably is going to be the most straightforward way to do this. So that would be my recommendation. What you would do is you'd set up an array. You could make it size 10, and then just remember to subtract 1 from the cow's ID number, because remember the cow ID numbers are going to be 1 through 10, not 0 through 9. Or we could have an extra. We could have a size of 11 and then just ignore index 0, because we would have no observations for cow 0. It would just be a non-existent cow. That'd probably be the easiest way to do it, honestly. Okay, so assuming I'm going to go with size 11 on my array, which is more than I have cows, then I'm going to have obviously 1, 2, 3, 4, 5, 6, 7, 8. So on the side 9, 10, 11, and I got cow 11 over here. Let me see if I can make a little more room. I just want to leave that blank space there as a placeholder to show that it's not going to affect anything. 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. Okay. So if I was to do an array, what I would do first is I would fill all these with -1s. -1 to indicate we have never seen that cow before. And that way we can distinguish between whether it's on side 0, on side 1, or herefore has never been seen. Cow 0, cow 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so we're just going to run only cow 3. I'm going to skip the other cows for now, and we'll look at just generally how this algorithm is going to work. So as I'm working my way down, I find an observation that cow 3 is on side 1. I check cow 3's current location, which is -1, which means I've never seen the cow before. Since this is a -1, I'm going to just clear this and put whatever side the cow is currently on here, which is 1, but I'm not going to qualify that as a crossing. So that's just replacing a -1 with the current observation. The second observation of cow 3 is location 0. I would check my array here and see that the current value is 1, which is a valid side of the road, which is different from the 0. So I would count that as 1 crossing. And then I would change this to a 0 because now I've observed the cow on side 0 of the road. Moving along, I've got other stuff with other cows. Here's another observation of cow 3. Cow 3 is on side 0 here, but if I look in the array, cow 3 was already on side 0, so that doesn't count as a crossing and nothing has changed. Cow 4, and then here's cow 3 again. Cow 3 observed on side 1. It's currently on side 0, which is a valid side of the road, which means that now we've got to update that to side 1, and because we're updating it, we're going to count that as a second crossing. So I've had 2 total crossings for cow 3. Now, the reason I'm doing cow 3 is I want to point out that despite the fact that I have 4 observations for cow 3, 1, 2, 3, 4, and also despite that the first observation is on side 1 of the road, the cows didn't start on side 0. We only have observations of where the cows are without any assumption of where they were prior to the first observation. So let's go ahead and run that with the entire test data here, and then I'll go through the way that you could do this potentially with dictionaries. -1. Okay, so going through all of the data this time. So cow 3 on side 1, cow 3 has currently not been observed on any side, so I'm going to set that to a 1, but I won't count that as a crossing. 1. I'm going to do crossing over here. I'll tally them as we go. Cow 3 on side 0, we just did this, switches to 0. That's 1 crossing. Cow 6 on side 0. Cow 6 has never been observed anywhere, so we will update cow 6 to side 0 without counting it as a crossing. Cow 2 is on side 1. Again, we've never observed cow 2, so we're going to put cow 2 on side 1. None of these qualify as crossings. Cow 4 on side 1. Again, we've never observed cow 4, so cow 4 will be placed on side 1. Cow 3 on side 0. We check cow 3. Cow 3 was already on side 0, so nothing has changed. Cow 4 on side 0. That's a crossing because cow 4 we already have observed previously on side 1. So I'll change that 1 to a 0. That counts as a second crossing. Finally, cow 3 on side 1. Cow 3 was previously observed on side 0. So I'm going to change that from a 0 to a 1, and that'll be a third crossing. And you can see our output here is 3. So basically what you're looking to do, again, is just keep track of the location of each cow, but make sure you're able to keep 3 states, whether they are on side 0, whether they are on side 1, or whether or not we've never observed them before, at which point any observation will not count as a crossing. So I mentioned there's one other way to do this using dictionaries or maps. This would be easiest to do in Python. So if you're using Python, maybe consider this. You also could do this in C++ and Java. If you're familiar with maps, it would be a good way to practice them. If not, it might be a good way to learn about them, but they are a little bit trickier to work with than arrays. Essentially what you're looking at doing is you've got your dictionary in the beginning that has no entries. When you observe a cow, you would check to see if its key is in your dictionary. So checking 3 is not in my dictionary. Since it's not in my dictionary, I would place it in my dictionary and I would set the value to 1. Then observing 3, 0, checking to see if it's in my dictionary. I see that it is in my dictionary and that its current value is 1. So I would change that to 0 and count as a crossing. And from there, it pretty much proceeds the same way. 6, 0, 6 is not in the dictionary, so I will put an entry for 6 on side 0. 2, 1, 2 is not in the dictionary, I'd put an entry for 2 on side 1. 4, 1, 4 is not in the dictionary, so 4, 1. 3, 0, 3 is in the dictionary already at 0, so no changes occurred. 4, 0, 4 is in the dictionary with side 1, so I would update the key, or I would update the value from 1 to 0, and I would count that as a crossing. Finally, 3, 1, 3 is in here with a value of 0, so I would update the value and call that a crossing. Again, doing it this way doesn't really save you any specific time. It's not necessarily going to be more efficient. It's just another way you could do it, and it's not a bad excuse to practice using dictionaries and maps. So that is how this problem works. Again, the larger test cases are at most going to be 100, so we don't have to do anything fancy. And we only are going to have 10 cows. And just remember this 8 here is not the number of cows. It's the number of crossings that have occurred. Alrighty, I think you're in good shape. Good luck coding it, and I'll talk to you on the next one.